Okay, so this is 4.7 chem, and then 4.8. But before I start, I need to explain electrolysis because, okay, yeah, because it's a new concept and we haven't done any CA on it. Because most of you are, I'm recording this, I'm going to be absent in week 11, so I'm not doing the week 11 CA, so I don't know how the questions will come. But it's pretty straightforward, yani it's just the same thing as the last one. Now we did the galvanic cell where you had two solutions or one solution, I don't know. You'd have the salt bridge, remember this one? Over here. Um, the salt bridge, and we had the metals over here. We'd have the more reactive one at the anode. Okay, and this is the cathode. And remember that the cathode would be positive and anode would be negative. It would be connected. Over here, you'd have like an ammeter or something, I don't know. And then you'd have another rod here. And we know that the anode one is more reactive than the cathode. This was what we call the galvanic cell. And the galvanic cell was used to produce an electric current from chemical reactions occurring. So basically, what the galvanic cell would do, it would change chemical energy to electric energy. These reactions are what we call spontaneous. Remember what spontaneous means? And they just happen. Hey, okay, we don't really have to do much. It just happens on its own. Now we're gonna see what happens in electrolysis. In electrolysis, it's the opposite way. You have electric energy and you use it to change it into chemical energy. Basically, here it's spontaneous. The reactions occur naturally. In electrolysis, it's non-spontaneous. When something's non-spontaneous, that means you have to force it to happen. Okay? That's why we need electric energy. We need a battery, we need some source of power source to force this chemical reaction to occur, and that's what we use electrolysis for. Electrolysis, I'm reading this over here. You can open the notes over here somewhere. Electrolysis has its uses and the definitions. This is just the app. I'm gonna summarize all of this in like 2 points. Over here, electrolysis. Basically, you have a power source, and same thing, anode, cathode, but they're in the same solution. Okay, the cations again go to the cathode, and anions move to the anode. Here's the thing. Here, here, the difference between electrolysis and galvanic cell, obviously, other than the obvious one, non-spontaneous and spontaneous, is that in the galvanic cell, we use two metals, right? We would see one metal more reactive than the other. However, in electrolysis, we use ionic compounds. And you guys know that ionic compounds, I'm just going to write compounds. Ionic compounds is metal plus non-metal, right? Or any electrolyte in general. That's why we say electro. Okay, any electrolyte. You guys know that acids and bases are also electrolytes, yeah? So basically, here we don't use two metals, we use metals and non-metal, acids plus bases. You guys know in ionic compounds, you have a cation, which is positive, and you have the anion, which is negative. Here's the thing. In the galvanic cell, at the anode, we'd have always oxidation, right? And at the cathode, we'd always have reduction. One mnemonic that someone told me about is red cat. Red cat basically tells you there is reduction at the cathode, okay? And if there's reduction at the cathode, that means there's oxidation at the anode. Okay, so it's the same rule. It's the same rule applies. We have reduction at the cathode, and we have oxidation at the anode. You guys know reduction is the gain of electrons. So you're gonna gain electrons. Which one do you think is gonna gain an electron? The positive one or the negative one? Which one's gonna attract an electron? Obviously, the cation. Why the cation? Positive attracts negative. So that's why the cation, or the positively charged metal, goes where? To the cathode. And the anion, the negatively charged metal, negatively charged, or we can say ion actually, goes where? To the anode. Remember, because the anode has oxidation. Oxidation, you lose electrons. So when you're losing electrons, you make it positive. Our goal here is to become neutral. To make the cation positive, it needs to attract electrons, so it needs to gain electrons. That's why we say it has in the cathode. And the anion, it needs to what's it called? It lose electrons to go back to neutral, and to lose it goes oxidation, because oxidation is the loss of electrons. So to sum it up, I'll wrap it up. Okay, in electrolysis, okay, it's basic setup. I'm gonna use this one here. Okay, where is it? Here? Okay, so in electrolysis, you need a power source. In this case, we're using a battery. You need to know that now in electrolysis, one thing changed, and that one thing is that the anode now is positive and the cathode is negative. Why do you think this is the case? Because we said that the positive charged ones go to the cathode, right? Let's say مثلا NaCl. If you're electrolyzing NaCl, okay? Na plus, the positive ones go where? To the cathode, Na plus. And the negative ones go to the anode. And this one's going to attract electrons, right? It's going to attract electrons. So for that reason, we place it on the negative side, and it's the negative electrode. The anode is going to lose, Cl minus is going to lose electrons, so it's going to become positive. That's why we place it on the positive side. So for that reason, we conclude that in electrolysis, the anode is positive, the cathode is negative. Okay? In electrolysis, we have two things. We have molten salts and then aqueous solutions. I'm going to start with molten salts. For those of you who don't know what molten salts are, it's basically when you heat NaCl salt to like a very, very high temperature, like 1000 degrees Celsius, it finally like actually melts. Because I'm sure, let me show you an example. So basically, this is how NaCl looks when you heat it to like a temperature of like 1000 degrees. It like melts, okay? That's what we call a molten salt. So over here, molten salts. There is a case for molten salts. Molten salts is easy, it's calm, it's nice, it's chill, okay? Always for electrolysis, we have cathode, anode, صح? We know that the cation goes to the cathode. So let's say مثلا molten NaCl. Molten salts, by the way, you need to know it's a liquid because you're going to need this in the quiz later. Okay, molten salts, obviously, they're liquids because you melted them. NaCl, what happens to the cathode? We get Na. Not Na plus, the product. I'm talking about the product formed. It goes from Na plus. What happens to Na plus? It attracts an electron to produce Na, solid. صح? This was aqueous. No. In this case, it was liquid, right? Because it's molten. This is the reaction that occurs, right? So at the cathode you get Na, not Na plus. You get. I'm not saying what's the reaction. I'm just saying what's the product form. You get Na, and at the anode, obviously you're gonna get Cl2. Be careful to this, huh? Many people they just put Cl. No, you guys know chlorine is diatomic. It's a gas, right? Cl2. How about NaBr? Very similar. Again, Na here, Br2. NaI. It's actually, yeah, NaI. Get Na, I2. Okay? These are the three exceptions because you guys know the halogens, FCl, they are all diatomic, huh? You have to know this. In case you see it, I'm pretty sure you see an example in the quiz. So this is for the molten salts. Let me see if I have any more examples in my copybook. CaCl2, yeah, this is a good. I'll use these two. CaCl2. Obviously here, please don't write the charge. I'm asking for the product. Ca and Cl2. Nice and chill. Al2O3. You're gonna get Al and oxygen gas because it's O2 diatomic, huh? I don't have any examples that are monoatomic. They're all diatomic in my copy. Okay, so this is for molten salts. It's easy, right? You just split it up. Always the metal goes to the cathode and the non-metal goes to the anode. Okay? Remember that the cathode is negative. It's the opposite. Remember, it's the opposite in electrolysis. The cathode is negative, the anode is positive. طيب. Second case. What if I have an aqueous solution? Okay? Aqueous solution. If it's an aqueous solution, we have a table you need to memorize. Okay? At the cathode, what will be produced, and at the anode, what will be produced. Okay. If you have Cu2 plus or Ag plus. Then at the cathode, you're gonna get what? Obviously, the metal goes to cathode. You're gonna get Cu solid and Ag solid. If not, you always get hydrogen gas. And you need to know the reaction for hydrogen gas. You have to memorize it. It's, I think, 4H plus, 2H plus, yeah. 2H plus 2E minus to produce H2 gas. You need to know this. This is obviously aqueous. You need to know this reaction. Okay? Think about hydrogen gas. How do you get hydrogen? It was obviously positive because, H plus. How do you change H plus to H2? You need to add an electron to balance it out, right? So H plus, you need to add an electron to balance it out. And since H2 just balanced 2, 2. Okay. At the anode, if Cl minus, Br minus, I minus, they have to be concentrated. If it's dilute, then it doesn't apply. If you have Cl minus, Br minus, I minus that are concentrated, then you get Cl2, Br2, I2. If not, so even if there's Cl, Br, and I, but it's dilute, not concentrated, if not, what do you get? Oxygen gas. Okay, how do you get oxygen gas? It's 4OH minus to produce O2, 2O2 plus 2, or is it 4E minus? What's the reaction? I think it's 4OH minus. Oh, no, yeah, it's this. To produce O2 gas plus 2H2O plus 4E minus. You have 4 minuses here, so you have to have 4 minuses here. OH minus will get you water and oxygen gas. These reactions, I know they're a bit new to you, so it's completely fine if it takes time to memorize. And I'm barely memorizing them, so it's fine. Don't think you're alone on that one. Maybe some notes to help over here. If it was concentrated, the reaction would be 2Cl minus. Okay, obviously at the anode, yeah, 2Cl minus to produce Cl2 oxidation, yeah, plus 2E minus. Yeah, this would be the reaction. And I'm not gonna write Cl, I'm gonna write X. Okay, let's say, because they're all minus, huh? It's like for all of them, this applies. 2 of whatever minus produces X2 gas plus 2E minus. So these are our notes for electrolysis. One thing before I start, the electrodes used are usually inert. So I'm checking my notes in case I missed something. Okay, yeah, they're inert. Later we're gonna use electroplating, but for now we're talking about inert. Yeah, this is easy. طيب. They're inert, the electrodes being used, because we don't want any other reaction to happen other than the one we're trying to force. Inert meaning it doesn't react, okay? Such as platinum. Okay, so the electrodes used are usually made out of platinum, and there was one in the notes they said it was platinum or graphite carbon, whatever. Platinum or carbon. In case they do ask, by the way, here, why this happens, why is it only CuAg, Cl minus, Br minus, I minus? It's in the notes over here. Here. The more reactive a metal is, the less likely it is. So, it's because Cu and Ag are less reactive than H+, and Cl minus, Br minus are less reactive than OH minus. If they ask this, they never ask it. But I'm just telling you, in case you see it, okay? It needs to be, in electrolysis, usually everything's opposite. Like here, we said they have to be more reactive in galvanic cell. But here in electrolysis, it has to be less reactive. Okay? طيب. Hello, the quiz. Okay? We're doing the electrolysis of molten calcium fluoride using the below apparatus. Which one's the cathode? Which one's the anode? Obviously, cathode always is the cation. So what are we gonna have? Ca. Oh, anode, obviously the non-metal, the anion, F2. Very easy. Write the chemical equation for the half reaction at the negative electrode. See here, people will confuse. They're gonna say negative electrode. Oh, that's the anode, because they remember it from the galvanic cell. But no, we're doing electrolysis. So the negative electrode was gonna be the cathode. And what we have at the produced at the cathode? Ca, always the metal being produced. So we started with Ca2 plus. And how do we change it to Ca? It needs to lose these two. So how do we do that? You add the electrons, right? Aslan, you know that the cathode always red cat. Reduction is gain of electrons. Remember, reduction is gain, oxidation is loss, right? Reduction is gain, so you're gonna gain electrons here. Okay. If they asked for state symbols, since it's molten, what's it gonna be? Liquid to get me, I think solid, liquid also. Yeah, to get me liquid also. Doesn't get you solid because it's molten. Okay. But they didn't ask for state symbols, so it just stays like this. Okay, هلا the half reaction at the positive electrode. Now the positive electrode would be what? The anode, because we're doing electrolysis. Remember, it's electrolysis is different. So anode, what do you have at anode? Always oxidation. And oxidation is loss. Okay. What do we have? F2 is being produced. Okay. F2, you don't write it as F2 to produce. You don't say F2 minus. No, guys, no. F2 is a halogen, group 7. Remember group 7? So it's F minus. Okay, so F minus, oxidation is loss of electrons. So it produces, what we're producing? F2, and you're losing electrons, so plus E minus. So we have to balance this out. You have 2 here, so you have to put 2 here. Now it's 2 minus, so you have to have 2 minus. If it was just more state symbols, obviously liquid, but you know F2 is a gas, okay? F, Cl, Br, I, all of the group 7 metals, in neither gases, okay? You have to know this. يعني when they're diatomic. Okay, so you get this. Question 2. Write the half reactions that take place at the anode and cathode during the electrolysis of aqueous solution of sodium chloride. Now they were working with what? Aqueous. What was our table? For the cathode, if it has Cu or Ag, you get CuAg. If no, what do you get? Hydrogen gas. So, what are my products at the cathode? I'm gonna write cathode without looking at the answer. I wanna focus here. Okay, at the cathode, it has to have Cu or Ag when it's aqueous. If not, you get hydrogen gas. So we get hydrogen gas here. At the anode, by the way, these again, I recommend you to do the notes. I'm probably gonna record CQDs. I like these questions a lot. The way they ask them, they're very good questions. You know what you get at the anode. After that, you get what do you call it? You learn, and you learn the subject 100%. You learn the topic. ونحن we did them in class. They help you. Wallah, they help you memorize. But anyway, at the anode, you need to have Cl minus, Br minus, I minus, and it has to be concentrated. Here they said concentrated Cl. So am I gonna get oxygen gas? No, I'm actually gonna get chloride, right? So I'm gonna get Cl2 gas. So what are the reactions? Okay, in هنا, I'm not even looking at the answer. I'm looking here. Okay, the cathode. How do you get hydrogen gas? Obviously, hydrogen gas. It's at the cathode, so it's reduction. So we're gonna, because red cat, right? At the cathode, reduction. What is reduction? Reduction is gain of electrons. So I need to add something. It was H plus. Obviously, I'm going to add electrons, gaining electrons to produce H2 gas. Okay, and this was aqueous. But they didn't ask for state symbols. But yeah, this is the answer over here. Okay. At the anode is oxidation. And oxidation is loss of electrons. So Cl, what was it? It was C minus, right? It's gonna get me Cl2, and I'm gonna lose electrons. Losing, and it's on the product side. Okay, let's balance this out. I have 2 here. Now I have 2 minus, so I have to put 2. Okay, so you get this. If they ask for state symbols, aqueous and gas here, right? Type. Question 3. Write the half reactions that take place at the anode and cathode during electrolysis of molten ZnCl2. Now, again, we're doing molten. Molten is so easy because بسرعة, you know the cathode, you know the anode. Cathode, you're going to get Zn. Anode, you're going to get Cl2, right? Cathode, anode. Okay, طيب. What happens at the anode? I'm not going to look at the answers. I'm going to write them from here, okay? At the anode, or I'm not going to do this in order. I will see the cathode. Remember, red cat. So reduction at the cathode. Reduction is gain of electrons. So we start out Zn. What's the charge of Zn? You guys know it's 2 plus, okay? Zn 2 plus, you're gaining electrons. How do I lose the, how do I balance out the, I'm going to add electrons. So how many do I add if it's 2 plus 2? To produce Zn solid. No, actually it's not solid. It's molten, right? Molten, so it stays liquid unless there's a gas being produced, okay? At the anode is oxidation. Oxidation is loss of electrons, right? So Cl2, it's gonna, sorry, no. This is the product I'm getting. Cl2 is the product. Here, these are both my products, huh? So we put them on the side. Cl2, it's losing electrons, so I'm gonna put the electrons here, right? Cl2, what was it? It was Cl minus. Cl minus. I need to balance the Cl, so 2. So 2 here. It's balanced now. What was it? It was molten, so it was liquid. But Cl2 is a gas. Remember, it's always liquid unless it turns into a gas. Okay, so let's check here. At the anode, it was this one. Yes, it's the same thing. Liquid gas and 2E minus. And then at the cathode, it's this one, gaining electrons uh, over here, liquid to liquid, because it's molten. Okay, that's for 4.7. Hella, we'll do 4.8. Okay, so now 4.8, it's very, very easy. But this is about electroplating. Basically, electroplating, um, it's almost the same thing, man. But there's two things you need to know. Okay, electroplating, basically, sometimes you want to make something. What am I doing? Sometimes you want to make a metal more pure. Okay, it can be used for two things. أول شيء to plate something with the metal. So مثلا your spoons that you use to eat, guys, in your houses are usually electroplated. And they do this, by the way, to prevent corrosion and to prevent rust. I'm pretty sure you guys know that our cutlery at home is made out of stainless steel, so that when water comes on it, it doesn't rust and react with oxygen to rust. Because you guys know if you eat rust, if you use a rusted fork to eat, you die. So basically, they use this electroplating to somehow force this metal onto your spoon or whatever metal you want to electroplate. There are a few guidelines you must know. You need to know that the object you want to plate, like the spoon in this case, has to be placed at the cathode. And you guys know that the cathode is negative. How does it come in the exam? They gave you the side of the battery, okay, and you have to see where on which side do I put the cathode. You guys know the cathode is negative, so you put it on the negative side of the battery. You guys know the negative side of the battery is the shorter one. You remember when we did physics? This is the positive side. This is the negative side. Okay. طيب. That's the first thing. You should know that they're dipped into a solution of electrolyte. Okay. The solution of electrolyte should contain the thing you want to plate with. Since we're plating the spoon here with silver, this solution I should have, it should have silver in it. Okay. To make it easier to electroplate. Very easy. Same thing. You should know that the cathode always gains weight. Okay. The cathode gains, and not weight, sorry, size. Okay, because it's being electroplated, and the anode in this case, let me write spoon, and the anode in this case loses size or shrinks. I don't know, loses size. What else can I say? Um, yeah, I guess that's it, Amy, because it's being oxidized. No, you guys know that oxidation occurs at the anode. Ag becomes oxidation is loss of electrons, right? Ag becomes Ag plus and E minus, right? So it was solid, turns into aqueous. Very easy. Electroplating is so easy. Okay, and like this one here, they even wrote it here. At the anode, Ag, the solid, basically what happens, it turns into aqueous, yeah? Okay, and this aqueous, Ag plus, it travels through the solution until it reaches the spoon, where the spoon is going to go like, oh, take an electron, and then become solid and join me over here. Okay, so when the Ag plus gains an electron, it becomes solid, and then when it becomes solid, it deposits onto the spoon. Okay, I hope you understood. I don't know what else I can say to explain more. Um, let's start. Okay, this one, question one, I don't know. This is supposed to be 4.7. Which of the following produces H2 and O2 during electrolysis? Okay, obviously, remember to get H2 and O2, it was our table over here. To get H2, it has to be a metal other than Cu and Ag. And to get O2, it has to be something other than Cl, Br, and I. Okay, here, concentrated Ki. No, because it's gonna get me I2, right? Concentrated I2, again, that's gonna get me I2. And also the Cu will get me Cu, right? It can't be Cu or Ag, and it can't be Clbr or I. Molten NaOH can be molten, no, right? It has to be, I'm talking about aqueous solutions. Remember, to get O2H2, you need aqueous solutions. Molten salts, you're always gonna get the salt. I mean, you're gonna get the product. You're gonna directly get the product. Dilute CuSO4. Here we can't because it contains copper, so I'm going to end up getting copper. K2SO4. It's not copper, not Ag, and there's no ClBrI. Please pay attention. If they said dilute K I, this would also be correct because they said dilute I. If it's diluted ClBrI, it will also give you O2. The only time ClBrI will give you the actual ClBrI as a product is when it will be concentrated. Okay. Question 2. Okay. Ryan was asked to plan an experimental protocol using his knowledge to coat a silver coin with pure silver. So basically, he wants to coat a silver coin with pure silver. So he needs to use electroplating, right? This is what we talked about. If you want to coat it with more metal, like you want to make a thin layer of metal above it, you need to use electroplating. Which process should he use? Obviously not this, guys. He needs to use electrolysis, right? Not this because, guys, when do we use a salt bridge? That's for the galvanic cell. This whole chapter, this whole section is about electrolysis, where it's two electrodes in the same solution with the coin and the pure Ag on one side. Okay, the coin is placed at the cathode, the silver is placed at the anode. Why? Now we want to coat the coin. Remember, the thing you want to electroplate has to be at the cathode. Okay, and you know the cathode is connected to the negative side. Okay, if this is the cathode, then the silver that's gonna lose its mass and size is gonna be at the anode, and that's on the positive. The half reactions, we'll do this fast. Obviously, we have silver at the cathode. Remember, a cathode is always reduction, red cat. It's gonna be reduction. Okay, reduction is gain of electrons. We're talking about silver, so it's gonna gain an electron to produce what? Ag again. If it's gaining an electron, that means it has to be plus, and here it's gonna be solid. Okay, أصلا at the cathode, it's where it gains mass. It's where it turns into a solid. Okay, you have aqueous, whatever. Okay, the half reaction that takes place at the anode. At the anode, this is reduction. This is gonna be obviously oxidation. Oxidation is loss of electrons. So Ag, it was solid here, right? It was solid, turns into an ion. So it loses an electron and becomes an ion, aqueous. This stuff's easy, guys. Okay, here the hydrogen fuel cell. Just read this over here. Pause, read this, and it memorize these, and you're good. It's just one concept. But basically, hydrogen fuel cell is like an energy source where hydrogen reacts with oxygen to produce water, and when it produces water, it releases like a shit ton of energy. Okay, and these are the advantages and disadvantages of it. So basically, what are the two things that react? Oxygen and hydrogen, and the product is water that releases a lot of energy. Okay. 4. Water forms by the reaction between hydrogen and oxygen here. The reverse is not spontaneous and can be forced by an electric current called what? When do we force a reaction that's not spontaneous by using electricity? It's when we're doing electrolysis, right? Okay. Oxygen gas is produced at the what? Hydrogen gas is produced at the what? Okay, if you remember our table, guys, over here, at the cathode we have hydrogen gas being produced. At the anode we have oxygen gas being produced. Okay, so at the at the cathode it's hydrogen, at the anode it's oxygen. Write the half reaction that take place at the anode and cathode. Okay, at the cathode, remember, red cat. These two, you must memorize them. For water, you must memorize them. Or you can understand them, and I'm trying to understand. Okay, I know that at the cathode, I'm getting hydrogen gas. Okay, so what do? I write H2O, because obviously I'm getting H2O. I'm starting with H2O, it's decomposing, and I'm getting hydrogen gas. Okay, then I have to start balancing. If you have hydrogen gas, that means, you guys know H2O gets you H and OH. So if I'm getting H2, I have to get OH over here. Then I have to balance, okay? You have to balance it out. Okay, to balance this, you put the 2 here. So you have 1, 2, 3. You have to put the 2 here. Okay? Akid, since you have 2 minus here, so you need to put what? 2E minus over here. This is how you balance it. Okay? And they didn't say state symbols, so this is your reaction. Now, at the anode, I'm getting oxygen gas. So same thing, H2O. I'm getting oxygen gas. Right? Type. You get O and what? H plus. Now, balance it. You have 2 here, so you need to have 2 here. Sorry, no. H plus. You have 2 oxygens here, so you need to have 2 here, so I multiply by 2. Now I have 4 hydrogens, so I have to put 4 here. Okay. And at the anode, I need to cancel out this positive charge. So do I put electrons here? No, I have to put electrons here to cancel it out. So 4 E minus. That's it. That's how I understood it. You can understand and memorize whatever you want. Question 5. Here, they have an electrolytic cell. Electrolytic cell, it's the same thing as electrolysis, huh? The pure, oh, is it? Galvanic cell. Uh, but, yeah, it's like electrolysis, yeah. The pure copper rod is placed at the wall. Okay, so basically they want to purify copper. Whenever you want to purify copper, that means you want to take the copper out of it, okay? It follows the same thing as electroplating, okay? Remember the thing when we wanted to plate over here, when we wanted to plate the spoon or the coin, we take silver out of the silver strip, yeah? So the one that would lose its size would always be the anode, right? Here in question 5, we want to purify copper, so we want to take the copper out of the ore. So that means the copper ore is going to lose its mass, so it's going to be the anode. You can think of it like that. Or in general, anytime you want to purify something, that means you want to take something out of it, so it's going to lose its mass, anode, always, okay? So the pure copper is the cathode because it's going to gain copper from the copper ore, which is obviously the negative, and the copper ore is the anode connected to the positive. Write the half reactions. Okay, the half reaction takes place at the cathode. Obviously, reduction, right? Reduction. Reduction is gain of electrons. So copper 2 plus will gain 2 electrons to produce copper solid, right? It was aqueous. Then at the anode, it's oxidation. Oxidation is loss of electrons. So Cu will lose 2 electrons to get Cu2 plus, aqueous solid. And this one you can skip it. It's not required for us, okay? Question 6. Concentrated HCl is electrolyzed using the apparatus below. Select, okay. Which one here is on the positive side? We know in electrolysis, anode is the positive. And which one here is on the negative? It's always cathode, right? So B is going to be cathode, A is anode. Why? Because the smaller side of the battery is always negative and the longer side is positive, okay? What happens when the circuit is switched on? You have HCl, concentrated HCl. When you electrolyze HCl, what's going to happen? We know that we're going to get at the cathode something and we're going to get something at the anode, right? Type. At the cathode, if it's aqueous, if it's Cu or Ag, we get CuAg or Ag. But we don't have it, so what we're going to get? We're going to get hydrogen gas. Remember our rules here, over here. Then, at the anode, if you have ClBrI concentrated, then you're going to get that gas. We have, it's hydrochloric gas, so HCl, hydrochloric acid, so HCl. So we have Cl concentrated, so what we're going to get Cl2 gas. Type. So what's going to happen when you switch it on? We're going to get these two. If it's a gas, effervescence. And chlorine is yellow-green, so a green gas will evolve. Okay? Level of liquid rise, all this, so we don't care about this, okay? The product at the positive electrode is what? At the positive electrode, it's what? The anode, right? What do we get at the anode? Cl2. And how do you test for the presence of chlorine? It bleaches litmus paper, you guys know. Question 7. Write the half. Okay, iron spoon is to be plated with copper metal. The electrodes are dipped in copper sulfate solution. Write the half reaction at the anode. At the anode, remember, anode is oxidation. So you're losing electrons. Remember here, don't get confused that it's iron spoon. No, we're plating it with copper, so we only care about copper. Okay? Oxidation is loss of electrons. So Cu is going to lose 2 electrons to get Cu2 plus, aqueous solid. By the way, the order in which you write it doesn't matter. Okay? The half reaction at the cathode. At the cathode, remember the cathode is the one that's undergoing reduction, red cat. And what's at the cathode? It's a spoon that's gaining mass, right? So reduction is gain of electrons. So Cu2 plus is going to gain 2 electrons to produce Cu solid. And then obviously aqueous over here. Question 8. Okay, which one can we use to electroplate an iron nail with nickel? If you're electroplating the iron nail, that means it should be the cathode, right? That means it should be the negative side of the battery. And nickel should be at the positive side of the battery. You should also know that when you're electroplating, it should be dipped in a solution containing the thing you want to electroplate it with. Since we want to plate it with nickel, we're not plating it with iron, we want to plate it with nickel. That means the solution should contain nickel. So I'm going to go through them one by one. I'll skip this one. أول شيء here the solution has sulfate. Do I want to plate with sulfate? No, يا أخي, no. Here we have nickel, but look here, the nail is at the positive side of the battery. We don't want that. If it's at the positive, then it's going to be the anode. I don't want it to be anode. I want it to be cathode. Remember, when you plate, it has to be cathode. Here, it's just nickel. We said nickel solution, right? It has to be something aqueous nickel in the solution. It can't just be nickel. So that's wrong. Aqueous iron sulfate carbon. There's no nickel here. Why is this one? We have a nickel solution, and our nail is at the negative side, so it's the cathode, and our whatever nickel is at the positive side. So it's going to be this one. Okay? That's it for question 8. Thank you so much for watching. Good luck.